Gamma, gyro-acceleromagnetosensors-based motion assistant. Driving force behind Gamma. 95% of the population in India suffer from gum disease, yet only 50% use a toothbrush and just 2% visit the dentist. Up to 4 billion people in the world suffer from untreated cavities in permanent teeth. 44% of the world population over the age of 65 suffer from periodic limb movements of sleep, also known as PLMS, yet most of them remain undiagnosed because of expensive monitoring facilities. The main aim behind our TIIC project was to bring as many as motion or movement related problems, such as the ones mentioned earlier, under one roof and to tackle them using a single electronic device, Gamma. Basic idea. The basic idea was to use the data of a 9-axis motion tracking IC and to apply suitable algorithm to interpret the data according to the concerned application. Then this data would be sent to the user's smartphone or computer via Bluetooth, and the user can access this data whenever he wishes to do so. TI's components used during the development of the project. Testing of individual modules such as the motion tracking IC MPU9150 and the Bluetooth module HC05 was done using MSP430 G2553 Launchpad. MSP430 G2553 IC was used in the final prototype as well. In the final prototype, we used TI's low dropout voltage regulator LM1117 to provide regulated voltage to the MSP430 G2553 IC. TI's sensor tag was used to experimentally verify that the data obtained from MPU9150 was correct. MSP430 F5529 Launchpad was used along with TI's sensor hub booster pack to acquire the 9-axis motion data and to perform the necessary filtering and computation. All the programming was done using TI's Code Composer Studio version 5.4. We wrote a Python program to plot the data obtained from TI's sensor hub booster pack in real time. Here we'll show you a video demonstration of the accelerometer's x-axis data being plotted in real time.
As you can see, the data obtained from accelerometer is noisy and cannot be used as it is in most of the practical applications. Therefore, we use the low-pass Butterworth filtering algorithm. Here is a video demonstration of the same. From the graph, it is clear that the abrupt and quick motion is ignored, and the high-frequency noise has been filtered out. The transitions are smooth and gradual. Now the filtered data can be used as per the required application.
Making the PCB. The schematic and board file were made using the free version of EagleCAD software. PCB was etched, drilled, and soldered by us in the lab itself. The given picture shows the various steps that we took while making the PCB. Demonstration of various components used in the present prototype of Gamma.
Presently, the board is powered by two 3-volt CR2032 coin cell batteries in series, whose output is then regulated by Texas Instruments low dropout voltage regulator IC LM1117, which powers the heart and brain of the circuit, Texas Instruments ultra low power consumption microcontroller IC MSP430 G2553. In order to be able to program the board as per the application, we brought out the necessary test, TIIC, VCC and ground pins. MPU9150, which was used in Texas Instruments Sense Hub, is used to acquire the 9-axis data. Bluetooth module HC05 is used to transfer the data wirelessly to the user's mobile.
Applications of Gamma. Here we will show you two of the several possible applications of Gamma. Gamma as toothbrush assistant. We identify which region out of the 4 shown here the user is brushing in using the roll angle of the toothbrush. Here you can see the plot obtained using the Python program that shows the roll angle in the 4 regions. Then depending on how little the deviation of the person is from optimum brushing time of 30 seconds per region, we assign points to the region and send the points and the time in seconds of each region to the user's smartphone whenever he wants to see it. Here is the video demonstrating the same.
Now, in his phone, the user can open the app for Gamma's toothbrush assistant, press the button Gamma It, and receive the points as well as time for the 4 different regions. Accordingly, the app will tell the user whether he has brushed a particular region good or not. Since the user didn't brush for long enough duration, he has been assigned a poor evaluation for all the 4 regions. This time, the user will brush with a better brushing technique. This time, the user brushed better than earlier. The optimum duration for a particular region being 30 seconds. However, he exceeded the brushing in region R, and since even overbrushing is harmful, he received a good evaluation rather than excellent.
Gamma is periodic limb movements of sleep detector or PLMS detector. PLMS sufferers tend to have sudden abrupt and periodic motion of limbs while sleeping. Such episodes occur every 20 to 40 seconds once they start. We use the accelerometer and gyroscope data to detect such motion, and if there is no motion in the next 40 seconds, we ignore it and assume it to have occurred because of natural causes, such as turning the side. Here is a video demonstrating this application. Since the person shook his leg 3 times within an interval less than that of 40 seconds, therefore, the PLMS count increased to 3. Here are some more possible applications of Gamma. We would like to thank our mentor Professor Dhananjay Gadre for providing us the necessary resources and Texas instruments for organizing such an event.